All right. So, do you guys know the word translations? Have you heard that word before?
Yes.
What would you say it is in your words?
Changing across.
So changing across, and so our full definition would be that it moves every point the same distance in the same direction. So we're going to write that out. Do you guys know the word vector? Yeah, that's not. So vector is just, my definition here is it has a quantity that has both size and direction. You guys know the word magnitude? Magnitude just means size. So component form is also known as vector form. Alright, so then component form, it combines the horizontal and vertical. So like for example, we have 5, 3. It's kind of like the xy coordinates, so it means it moves it 5 to the right. Five to the right, and then 3 up. Is that logical to you guys? If we have x, y, so positive means move to the right. What would happen if I put -5, -3? Left and down. And it's when we have these symbols rather than just the parentheses like down here. Alright, and then just when we're dealing with translations, the image is what we call the new figure. So after we've done the translation. And pre-image is the original figure. There's an R. You get it? Alright, so when we're doing translations, we have, sometimes it's written like this is telling me x minus 6, y plus 8, or that could be written out as in vector form as just -6, 8. And so the difference is, it's just a format difference. So if it has these, that's our vector form. That's the way it's written out. So there's 2 ways we can do this. We can count in the graph and just like take point A and count backwards 6. And then up 8. And that is our A prime. So the new figures always have the apostrophe or a little markup here, and that's called prime. And then I can label my point. What are the coordinates of this point now? -4, 5. So some people like to just count it out and graph it. Some people like to label the original point. So what are the coordinates of original B?
2
to negative 8. And then I can just do the math of doing 2 minus 6, which is what? And then negative 8 plus 8 is 0. And then if I count it out and graph it, that's going to be the same. It'll come out to negative 4 and 0 if I just counted the negative 6 and the plus 8. That's going to be prime. Which way do you guys like better? Graphing first and labeling, or labeling and doing the math? Okay, so go ahead and take, actually here, I'm going to do the first one of example 2, then y'all are going to finish this in your groups. So here we're just describing the rule using vector form, so remember that's going to be this form. And so all I have to do, remember when I'm matching these up, is there's 4 points to A. I have to match them up to the same 4 points of B. So if I start with the top corner here, I have to come all the way over and down to the top corner of B. I can't just go to this side. So that's the only thing people sometimes get mixed up here. So I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be positive 10 because I'm going forward, and then down 5. Okay, so we're going to take like 3 or 4 minutes, see if you can label the last 3 points of example 1 and do numbers 2 and 3 of example 2. All right, and what did you get for the last one? I have something different. Yeah, negative 12. Negative 12, negative 1 when we go all the way to that corner. It has to be the same corner. So like from whichever corner you do, I come over, like if it's this one, I come over 2 and down 1, 2, 3, 4, 5, 6, because I have to match it to the bottom. I know that's the thing people get mixed up most with these, is matching it all the way to the last one. All right, so go ahead, when you have that, flip to the next page. Okay, and before we get to rotations, you guys get to, again, do this in your groups. See if, a lot of people get a little mixed up with these directions. See if you can figure out how to do it and draw something, what type of shape you'll make from it, or what type of figure. So go ahead and work on that for a minute or two. So if you got through that, that made a cube, beautifully symmetric cube. Okay, so our rotations are, what is a rotation? Yeah. So it's turning it around a fixed point. The center of rotation is just the fixed point. If we're asked about an angle of rotation, it's the angle we make drawn from the point. And then we have something that's rotational symmetry. What does symmetry mean? Yeah, it is. So like you can fold it on top of half or something. And so if it's rotational symmetry, it just means if you rotate it at 180 degrees, it'll be exactly the same. So like the two halves are the same when you rotate them. So that's what we'll write down. And so this is our technical wording, and can be mapped onto itself, which means it lines up exactly on top of itself. Alright, and then this figure down below is like your little cheat sheet for rotations. Some people find this really way easier to come look at this and figure it out. You won't get it for a quiz or test, but like as you're doing your assignment. Some people find it easier just to like rotate your page and label points, which is what I'm going to show you next. But it just shows you if you have a point here and you rotate it 90 degrees counterclockwise, you'll switch to coordinates, make one negative. If you do 180 degrees, the coordinates just change symbols. And then if you do the 270 degrees, it's going to from the original change, and then the A becomes negative. And if that doesn't make any sense, don't worry about it. So once you have that, flip to the next page. Yeah, it doesn't usually make sense until we at least go through the process, and then looking back at it can make more sense. Okay, so when we rotate, we can rotate either clockwise or counterclockwise.
I like clockwise because the clockwise, it don't let it go tick tock.
Yeah. But sometimes you'll get problems where they say counterclockwise. So that's the first thing in rotations. Make sure you read directions and see which way you're rotating. It does matter. And it's determined just by degrees. So 90 degrees, if we're turning that into fraction form, would that be quarter, half, 3/4, 1 full, quarter? Yeah. So 90 degrees is just a quarter turn. 180 would be half turn. If we're doing it 180 degrees, does it matter if we turn clockwise or counterclockwise?
No.
No, because you're turning, it doesn't matter, it's going to end up the same. So 270 degrees is 3/4 turn, which is the same as a quarter in the opposite direction. And then 360 degrees, just one full turn. Is there any change if we rotate 360 degrees?
No.
No, it's exactly the same. Alright, so who can tell me, A, how could we describe this turn?
Wouldn't it be 90?
Yeah, 90 clockwise.
90. I'm sorry.
And how else could we describe it?
One's 250 counter.
Yeah, 270 counterclockwise.
Should I explain it two ways?
We're going to look at these because usually like your assignment, it'll give you one or the other. I just want you to recognize that those are the same. Right, how about the second one?
That's a 90 degrees
Counterclockwise.
And 270 clockwise.
I abbreviate counterclockwise. Counter.
Yeah, you can abbreviate in your notes as long as you understand it. And what is C?
That is 180.
180. Okay, so this is asking us to draw the result when we do it. And so, to me, the easiest thing that makes sense to me and to most of my students is to actually turn the paper and label points and then graph it. So before we do any of that, let's label these points. What is A here? I'm going to write it off to the side. So negative 4, 2. What is B? Negative 7, 7. And what is C? Okay, so those are our original coordinates. It tells me to rotate counterclockwise, so I'm going to do the 90 degrees first. 90 degrees counterclockwise. Easiest thing to do is just turn your paper 90 degrees counterclockwise. Okay? And now we're going to label these points, which will be our A prime, B prime, and C prime, as if the paper wasn't rotated. So if I look at it this way, what's my A coordinate now?
Oh, you just grabbed the same thing.
Yeah, so I'm just labeling. So it's negative 2 to negative 4. Pretty much. And they're both going to be negative when it's in this quadrant. B is negative 7, negative 7. And C is negative 3, negative 9. So if you look at that pattern, what happened to do the 90 degrees counterclockwise is we switched them, and then they both became negative, because in this quadrant everything's negative. So now I turn my paper back and then graph those points down here so that I actually have it. So negative 2, negative 4, negative 7, negative 7, and negative 3, negative 9. This graph, not every graph is 10 units, but this graph is 10 units, so that helps with counting out and graphing. Does it look like we took that image and just rotated it over?
Oh, isn't this supposed to be negative 9, negative 6? Oh, you're so right.
It is. You're right. So it should be negative 9, negative 3. And so let's see if I can fix my paper. This is just going to be a messy graph. Alright, should we keep going together, or do you want to try the next two on your own? Pretty sure that was it. Do you guys need me to keep going? Okay, so if you think you can do it on your own, go ahead and try it. I'm seeing enough blank looks that I'm going to go ahead. So 180 degrees means I turn it all the way over. And so again, I'm looking at my original image just for the 180 degrees. And so I'm going to mark A, B, and C with 2 marks this time to show it's the second one. And so this time, A is 4, negative 2.
1, 2.
And then this 7, negative 7. And what's C this time? So 180 degrees. How did it change from the original? Yeah, same points, it just switched the signs. So 180 degrees is really easy because you keep the same points, just switch the signs. And so I'm going to graph that one now. Make sure phones stay out of sight, so don't check whatever message dinged.
Do we have to label on the graph?
It doesn't tell you have to, so it helps sometimes to track it, but it doesn't tell you you have to label the ABC, you just have to graph it. Alright, and then 270 degrees counterclockwise means I'll rotate it like this, or 3 times around, or 90 degrees clockwise. And I'm going to write it on this side of the graph. Was that too fast?
Work me.
Alright, so what's A this time? Two and 4. What's B?
7,
Mm-hmm. And then C is?
3, and 3.
No. 9 and 3, right? Okay. And so then we just flip it back and plot those last 3 points. And then we look at our drawing. Does it look like you've rotated it correctly all the way around? Alright, so if you haven't quite finished graphing, pause what you're doing and look up here for a second. I just got to show you one last thing. This is a piece of see-through paper I have, which you don't get to use when you're doing your work, but it helps you just see how the rotation works. If I lay it on top and trace the original one, and I just do the turns, I can check to make sure that I did everything correctly, just so you can see it if you weren't able to see without that. Oh. Did I graphed
it last year.
I graphed A wrong, didn't I? Okay, I will have to fix that, so I didn't do it right. And so, that just gives you the visual, if that helps. Do you guys notice the patterns here of how, the other thing that can help is just noticing the patterns of how they change, or how you don't have to keep counting out real carefully every time, because the numbers always stay the same, they just switch places and signs, depending on which quadrant we're in.